All right, so now we're going to get to the harder factoring. We'll spend at least a couple days doing this one to get used to it. Okay, sorry if the recording got messed up, like something weird happened, but okay, so factoring with the number in the front kind of changes the ball game, if you will. It definitely makes it more challenging. So first, these problems that you see at the beginning will not be very difficult if you remember one thing at the beginning. So if you remember, kind of going back to the very beginning, the first thing you always ask in these problems is what's in common. So 5, 15, and 10, I can divide all of those by 5. So when I divide them by 5, it creates a problem where there's no number in the front, which is definitely a game changer. So then after we do the what's in common, I always write like this parentheses like I do, and then I want to figure out the signs, and we've talked about that before. Like the last sign is positive, so the signs are the same, both positive or both negative. The 3 is positive, so that means I choose positive. If the 3 was negative, I would put both negative. Okay, and then x and x. And then step 3 is kind of a different thing. I just, it's kind of like what type of factoring. So we said there's 4 different types of factoring. This is the first one that we did. Just what times what is 2 that adds up to 3. 2 times 1. Okay, so excuse me. The first 6 problems are all like this. You will figure out what's in common, and it will end up with just x squared at the front. Okay, or a squared or y squared or r, whatever letter. And then you'll do what times what adds up or what times what subtracts based on this last number. Okay. I'm trying to think of a problem. Let me do another one if I can make up one in my head. Let's use 5 again. Okay, so on this one, take away 5, x squared plus 3x minus 4. And so when we do our parentheses, figure out the signs, the last term is negative. That means 1 of each. So this one is what times what is 4 that subtracts to equal 3. Okay, you kind of follow this, number here and you go this way. And then because it's minus, you say negative. Like up here, or it's negative, so you say minus. Up here, you say add because it's positive. Okay, so, well, what times what is 4 that subtracts to equal 3? Well, that's 4 times 1. Now, with one positive, one negative, again, it matters which one's positive and which one's negative. So I could have negative 4 and positive 1, or I could have positive 4 and negative 1. Which one of those makes positive 3? That one. Okay, just a second, guys. I'll be right back. All right, I'm back. Probably was only a second or two on your thing, but okay. So first 6 problems, will be like these. Take something out. You'll either do what times what adds, up here, or what times what subtracts. Those should be stuff that if you've been working on the problems, not an issue. Okay, so now kind of the crux of the new stuff. So if we had this problem. Okay, so side problem. Let's go over here. If we were like multiplying out this problem, this has nothing to do with this problem, but I'm going to illustrate something. I get 6x squared there, and I get 9x there, and I get 10x there, and I get 15 like there. So, there's 5 things here, but remember I forgot to put plus. We're gonna combine this 9 and 10 in the middle. But what I wanted to illustrate is this. This 6x squared comes from multiplying 3x and 2x. Okay, so if I wanted to end up with 6x squared, I could have also done 6 times 1. If I did 6x times x, like that still gives me 6x squared. But what happens is it changes this middle part. Because instead of doing 3x times 3, I would do 6x times 3. And now that 9 is an 18 instead of a 9. So it changes the middle part. It doesn't change the beginning. So, if I wanted to end up with a 6, I could do 3 times 2, or I could do 6 times 1, and it works. Okay, same thing like at the end. This 5 and 3 gave me the 15. Well, so like I got 5 times 3 and that gave me 15. If I put 15 times 1, it will also give me 15, but it will change this middle part. Okay, so, when we finish the problem, 9x and 10x is 19x. So, when we're starting the problem, remember we're going backwards. Like if this was the problem and we wanted to get that as the answer, we have to deal with these like, well, which combinations of numbers, 3 times 2, 6 times 1, 5 times 3, 15 times 1, like which combination make this middle number work? Okay, and so the other thing that I want you to notice, and then we'll come back and do our problem, is the 9 comes from this 3x and this 3. Notice it's a red with a blue. Okay, and then the 10x comes from the 5 and the 2. Another red and blue. So it's one of these numbers on the red part on the left side with one of the blue and then the other one. And then when you combine them, I got a red and a blue gave me the 9x, and a red and a blue gave me the 10x. Then when you combine them, they had to make 19. All right, so coming back over here, is there something in common? No. What are the signs? They are both positive because those are both positive. So you can kind of remember it that way too. All right, so then I always put an X in just because I know it's going to end up there at some point. Okay, so now we need to kind of list out like, well, what times what is 4? Okay, well, 4 times 1 and 2 times 2. So if I put a 4 and a 1 here, that's going to make 4x squared. If I put a 1 and a 4, that's going to give me 4x squared. If I put a 2 and a 2, that's going to give me 4x squared. I could have any of those, and this first part will be correct. But I don't know which one because the rest of the problem, like it has to fit together. So here, something nice with this one, 3 times 1 is the only way to make 3. Okay, so now I need to figure out like, well, remember it's one red with one blue. One of the numbers on the left with one of the numbers on the right, and then the other ones. So if I were to do like 2 times 3 is 6, and 2 times 1 is 2. 6 and 2 make 8. I need it to be 13. So that doesn't work. It really is just trying to like guess and like check to see what works. If I did 4 and 3 and 1 and 1, so 4 and 3 is 12, 1 and 1 is 1, 12 and 1 is 13. So that's, I'm going to use the 4 and the 1, and I'm going to use the 3 and the 1. Now, I can't just shove it in there. Okay, I've got to like put it in so that it works together. Because their signs are both the same, I can pick either the 3 times 1 or the 4 times 1 and just put it in. Then I have to match it. So I'll put the 4 and the 1 like that. Okay, so the 4, notice there's like an arrow like going, the 4 has to go to the 3. So if you come back over here, this first 3x, that arrow goes all the way to the outside. So the 3 has to go here. And then the 1 would go there. Because when we start to distribute things out, that's the 4x squared, and 4 times 3, there's the 12. Okay, if I reverse the red numbers and I put the 3 on the left and the 1 on the right, I would get 4 times 1, and that's not what I want. So the answer to the whole thing is that. And it really is just guess and check. See what happens. Okay. Okay, so let's do another one. And I'll add in another like part. Okay, so again, is there something in common? There's not. What are the signs? The 7, the last term's negative, so it means there's 1 of each. Okay, what times what is 2? That's nice because it's just 2 times 1. And then what times what is 7? 7 times 1. Oops, let me change the color so I can be consistent. The difficulty here is I don't want, if I did 7 times 1, that's 7. I want negative 7. So it's either negative 7 and positive 1, or it's positive 7 and negative 1. So it's kind of doubles all the options like of that last part, because you have to do positive this and negative this and like whatever. All right, so now it's just, again, like the x's go here, and it's just guess and like see what happens. Now I do want to end up with a negative 5. So this doesn't happen 100% of the time, but it's pretty high. If that is a negative number, the bigger number of this red part is probably going to be used. If that was a positive 5, then chances are the bigger number over here needs to be positive. So if I did 1 and negative 7 and 2 and 1, so 1 and negative 7 is negative 7, and 2 and 1 is positive 2, and that does make a negative 5. Okay, so I got it. There's what I want to do. Okay. So now here, this one is a little bit more challenging because I can't, the signs are different. I can't just put the numbers in. Okay, so I'm going to use a 2 and a 1, the blue one, and I'm going to use a negative 7 and a positive 1. So what happens is this 7 is negative. All the other numbers are positive. So the 7 has to go right there because that's the only negative sign in the problem. Okay, which means the one that kind of pairs with like the red has to go here. Then the negative 7, if you follow the arrow, goes with the blue 1. Okay, negative 7 goes with the blue 1. So that means it has to go there. Okay, because remember we're going to distribute. There's our 1 and negative 7. Okay, and so then that means the 2 has to go there. Okay, and so kind of getting rid of all the arrows and whatnot. Okay. So it can be challenging for sure to do this. So let's do one more. Oops, I don't need parentheses. Kind of a little bit more difficult one. So 6x squared plus 27 plus 20. Okay, is there anything in common? Well, remember, work with odd numbers because there's less stuff in common with odd numbers. So 27 doesn't go into anything. So let me see. What times was 27? 9 times 3. So does 9 go into any of those? No. Does 3 go? 3 goes into 6. Does 3 go into 20? No. So nothing's in common. All right. Write our signs. They're both positive, so both positive. Okay, what times what is 6? 6 times 1, 3 times 2. What times what is 20? 20 times 1, 10 times 2, 5 times 4. So now I got a whole bunch of combinations to look at. So which pair of red numbers combined with which pair of blue numbers is going to get me 27? Well, 27 is not that big, and so here's kind of what I do. I don't want to like guess like all kinds of them. I'd rather be a little bit strategic. So if I did 6, this red 6 times 20, that's 120. That's too big. It's probably not going to be that one. If I did 6 times 10, that's 60. That's still too big. Probably not that one. 6 times 5 is 30. 6 times 4 is 24. That's closer, but still 6 times 5 is 30. That's already too big. I'm guessing the 6 and the 1 are not going to be part of the answer. So I'm going to stick with the 3 and the 2. And then the 3 and times 20, that's 60. That's too big. 3 times 10 is 30. That's too big. So I'm going to start with the bottom. So I'm a little bit strategic about my choice there. And you can kind of work your way through it like that also. But okay, 2 times 5 is 10. 3 times 4 is 12. 10 and 12 is 22, not 27. So that's not it. But I could switch them. Let's see what happens there. So instead of the 2 going to the 5, I'm going to have the 2 go to the 4, which is 8. And then the 5... Oh, I messed up. The 5 with the 5 goes with the 3 is 15, and that's 23. And I really wanted that to be 23, so I messed up. Okay, so I'll change it back. So there's the combination that gives me 23 in the middle, even though I had 27 there at the beginning. Okay, so again, because the signs are the same, I'm going to use 3 times 2, and I'm going to use 5 times 4. I can put one of them in the problem from the get-go. And then I got to match them up. So the 3 goes with the 5, so that means the 5 has to be the one that goes over here, because the 3 and the 5, when I distribute, will go together. And then that means the 4 goes there. All right, so it's challenging for sure, but it's just a matter, you got to try these. Okay, so we'll do some today, and then we'll continue some stuff tomorrow, and I'll give you some more examples tomorrow. Okay, all right, have a great day, guys. We'll see you later.